Okay, our next topic area is the circular functions. And so it's similar to what we've done last year, and we're extending some of the stuff. So first of all, Radian, just a reminder that a circle with radius 1 has a circumference spelled that wrong, but don't worry about that, of 2 pi radian. Now, of course, if we go around the whole circle and measure the angle around in the middle, that's equivalent to 360 degrees, of course. So there's a relationship between the circumference around a circle of unit 1 and 360 degrees. So works out that 1 radian is 180 degrees over pi, and 1 degree is pi over 180. Alright, so for some quick conversion, if we're going from degree to radian, you then got to times by pi over 180. And if you're going the other way, radian to degrees, you are timesing by 180 on pi. Alright, so exact values is the next one, and certain angles, and the first quadrant ones are 0, pi 6, pi 4, pi 3 and pi 2, have exact values for sine, cos and tan. Now you're expected to know those, because if you in exam 1 need to know what the sine of pi 3 is, then you need to know that off the top of your head. So you either need to commit those to memory or know a way of working it out. Now, there's a handout with that stuff on it, so you can grab that. It's the same handout that you had last year. The handout lists the whole 4 quadrants. Alright. Now, once you've got that, of course, you can work out the other quadrants, ES. You can work out the other quadrants once you know the first quadrant ones. So the angles in the second, third and fourth quadrants relate to the first quadrant. Right, and that's what we call symmetry properties, and you need to know those, or certainly know relationships to work things out. So again, there's a handout with those written on them, which is great for exam 2, where you've got your bound reference, so you want to be putting those in your bound reference, those two. It's not going to be any good for exam 1 though. Alright, let's look at some examples. Okay, so here's the first example. So cos of pi 4, so if we do 5 pi 4, I should say. So if we do just a rough sketch is all you need. So 5 pi 4 is 4 pi 4 to is 1 pi, so it's another quarter further on. So that's that angle out to there. Now the key thing here is that this angle in there is pi on 4. Now we're after cos, so cos, and cos is this part here in the second quadrant, so cos is negative. So what do we know about that is that cos of 5 pi on 4 is going to be a negative, and it's going to be the same value because of this angle here being pi on 4. It's going to have the same value as the cos of pi on 4. And so of course that's going to be negative root 2 on 2. Similarly over here, sine of 11 pi on 6, well 12 pi on 6 is a whole circle, so we're not quite getting to the circle. So that red one I've done is 11 pi on 6. So that means that this angle in here is pi on 6. Alright, so there's a relationship then. Oh, and sine, of course, sine is this side up here. So this quadrant, so the sine of 11 pi on 6, this quadrant sine is negative, and it's going to be the same size as the sine of this angle, which is pi on 6. So the answer there is negative 1/2. Right, so that's one thing you can look at it as an example. Another thing, another kind of example, another time for example is this. So you're given some unknown angle at x, and told what its sine or its cos value is. So again, we can use a rough sketch, and so the angle we're looking at is pi, and so pi goes all the way around to the negative x-axis minus x. So minus x comes back this way. So if we put a line there, so this angle here is pi minus x, because this angle in here is x, and remember, of course, negative means going in the opposite direction, which is for angles clockwise. Alright, so what do we know from that? Well, the sine of pi minus x, so if there's the line there, the sine is this side out over here, so it's the length of that, and so the sine of pi minus x, well, sine in that quadrant is positive, and it's going to be related to this angle, the one between the x-axis and the line, and so that is going to be related to the sine of x, and the sine of x, we were told up the top is 0.6, so this one here is also 0.6. Alright, mentioned briefly about negative angles before, so here we've got negative x, so that means in the negative direction, that way we go x. So here we've got our line, there it is. Sine is this side there, and so that's now in the fourth quadrant, and sine in the fourth quadrant is negative, and it has the same value as this angle here, which was x, sine of x, and so that's negative 0.6. Alright, the next thing is what's termed complementary relationships. complementary relationships, and you might have remember or you might not remember about complementary angles add up to 90. So the complementary relationships is the relationship in a quadrant of sine and cos. Now, there's more stuff in your text, more details in your text on page 264 about it. Okay, so you can look at that if you want. However, the relationships are these. Right, so there's the relationships between sine and cos, the complementary relationships. So really all that's saying, this first one here, the sine of pi on 2 minus theta is the same as cos theta. So all that's actually saying is that, say, the sine of pi on 3, for example, is going to be the same as the cos of pi on 6. Alright, so because to get pi on 3, it's pi on 2 minus pi on 6. So that's all those relationships are about. Again, there's more in your textbook about them. So an example would be something like this. If sine of theta, I should say, equals 0.3, find the cos of pi on 2 plus theta. Alright, so when you look at those relationships on the previous page, so the cos of pi on 2 plus theta, it's this one at the bottom, and so it's the same as negative sine of theta, and that means it's negative 0.3. Alright, the last thing for today is what's known as the Pythagorean Identity. I've spelt that pretty badly. No, here we are. That's supposed to be an N, this one. That's an N. Pythagorean Identity. Now, you will have seen this before. Cos squared theta plus sine squared theta is equal to 1. Alright, and so that's the Pythagorean identity. And so we can use that to solve some things. So, example. Oof, that's terrible, even for me. So, given sine x equals 3/5 and pi on 2 is less than x is less than pi, find something. So cos x in this case. Alright, so we've got some information, we've got some things here, we know that. We've got what the sine x is. We've got this bit of information here, which we're going to use later, but that tells us that angle x is between pi on 2 and pi, which hopefully you've already recognised as the second quadrant. Alright, so the second quadrant, of course, when we're relating to cos is negative in the second quadrant, so we will use that later. So let's have a look then. So if cos x, cos squared x plus sine squared x is equal to 1, then we've got cos squared x, and sine is, sine is 3/5, so 3/5 squared, and that's equal to 1. And so cos squared of x is equal to 9, not equal to, plus 9 on 25 equals 1. So cos squared x is 1 minus that. So cos squared x is, and when you work it out, 16 on 25. Now, of course, to get rid of this squared here, we would need to square root both sides. So cos x would be the square root plus or minus of, is it 16 on 25? Now, we already said that this is in the second quadrant, and the second quadrant cos is negative, so it's got to be the negative value. So we don't want that one. So the cos of x is equal to negative 4 on 25. Oh, not 25, on 5. All right. So that's it. So on your work plan, and your sub should have that again. So this is 6A, 6B and 6C. All right, gone through a fair bit there reasonably quickly because we've done this stuff last year.